In a recent blog post and video, I showed how to make a population pyramid for Benton County, Oregon. Today, I'm going to show you how to take that code and turn it into a function that can make a population pyramid for any county in Oregon. Let's dive in. To start out, I'm going to load 3 packages. I'll load the tidyverse, which I'll use for general data wrangling and plotting. I'm going to load the scales package to make nicely formatted values, and patchwork to stitch together multiple plots. Next, I've got code to create the original population pyramid plot that I did in the last video. I'm just going to run all this, creating my plot, which you can see right there. Make it just a little wider so we can see it better. Now the age labels in the center are being cut off, but depending on the ultimate size that you use, they wouldn't actually be cut off. Next, let's take the code that I wrote to make a population pyramid for one county and turn it into a function. When I made my population pyramid for Benton County, I started out with my Oregon population pyramid data, and then I filtered to just show Benton County women, and I made a plot called population pyramid women. I then did the same thing for population pyramid men, and just to show you, if I just run population pyramid women, we get that side of the plot. Population men, we get that. And then I had age labels plot, which just shows up in the middle, and I stitched them together using patchwork. So now I'm going to create a function to make a population pyramid, because if I look at it, the plot on the women's side and on the men's side is really just about the same thing. So my function will have 2 arguments, county to filter and gender to filter. And what I'm going to do, you can see this starting on line 140. I'll start with my Oregon population pyramid data. Then I'm going to filter so that county equals county filter, and same thing with gender. What that allows me to do is I can pass as an argument in my function the name of any county or either gender, and that will enable me to make my plot. Let me show you how this works. Okay, let me run my function now, population pyramid single gender plot, where county to filter equals Benton and gender to filter equals men. Looks pretty good. Let me try running this for women. That's not right. I'm not seeing any of my bars. To see what the problem is, take a look at line 161. See where it says limits equals C 0 to max percent? So if max percent is around 8, maybe 9%, our limits are going from 0 to 0.09. But all the values for women are negative because that's how we make our population pyramid. So that's why we don't see any of those bars. There's one other issue with our x-axis limits. Take a look at our function now if we switch county to filter to a different county. I've changed it to Multnomah County, which is in Portland, where I live, and take a look at our resulting plot. Do you see how the limits still go all the way out to 8? Well, that's not great because for Multnomah, no group is higher than, say 5%. So it would be nice if we could make our x-axis limits dynamic. To make our x-axis limits dynamic, I'm going to make 2 changes. Let's start by looking at lines 202 to 208. You can see there I've said if gender to filter equals men, then set my limits to be from 0 to max percent times 1.1. I've added that times 1.1 just because I've noticed with some of the other counties, I need just a little bit of padding to ensure that nothing gets cut off. The most important thing that I'm doing, however, is I'm saying if gender to filter is women, then set our x limits to go from negative max percent times 1.1 to 0. So in other words, they're going to go below 0, which is what we need in order to ensure that the bars for women show up. The other thing that I've done here, you can see on lines 193 to 200, where I'm setting the max percent within my function. I've scrolled back up to my code where I previously calculated max percent. And you can see that here I've hard-coded Benton on line 57. And obviously that's not going to work if we're trying to make a function that works for any county. So scrolling back down to our updated function, you can see here on line 195, where I'm saying filter so that county equals county to filter. So in other words, whichever county we're using, when we use this function. Okay, I have run the code to give me the updated version of my function. I'm going to run this for Benton County, and you can see that looks good. You can see that our x-axis limits now go up to 10%. That's because we gave it that little padding by multiplying by 1.1, in other words, 110%. Let's run it for Multnomah County and see what happens. Look at that. The x-axis limits update dynamically, now goes up to 5% for Multnomah, which is perfect. Okay, let me run my code now for Benton and women to make sure that I can see those bars. And I can. Perfect. The issue, though, is I can no longer see that gender label. Let me scroll back up. So if I run this for men, you can see we've got that men label. But if I run it for women, I can't see it. And the reason why, if I look at the annotate function, specifically look at line 220. You can see that I am specifying that the label should show up at an x position of 0.05. But for women, our bars go to negative numbers. So by putting it at 0.05, it's just not going to be visible at all. To ensure that our gender labels are visible both for men and for women, I'm going to create a variable called gender label x position and set that dynamically based on whether we're making a chart for men or women. So take a look at lines 275 through 283. And if you focus on line 277 and 282, you can see that I'm saying, if it's men, keep it at 0.05. But if this chart is being made for women, let's set the position to be negative 0.05. So I'm going to run this function, and now I'll run my chart for men, and let's try it for women. Boom, I've got women at negative 5%. The next issue that I want to deal with is the fact that at this point, our function produces bars and gender labels in dark green, both for women and for men. But in the population pyramids that I made for Oregon by the numbers, women were in a lighter green and men were in this darker green color. So I've scrolled back up to the current version of my function. If you take a look at line 292 and 298, you can see that both for the bar fill color, as well as the fill of the label for women or men, the fill is set to a dark green. To deal with this, I'm going to add some other variables to my if statements. I'm going to scroll down here and take a look at line 342 to 354. You can see that I've added a variable called fill color, and for men, it's going to be that dark green, and the gender text color is going to be white. Now that specifies the color of the text. You can see that women here is white, although we're going to want to change that. For women, we're going to say the fill color should be a lighter green. And just to improve the contrast, we're going to set the gender text color to be gray 30. So now I've scrolled down in my function, and if you look at line 363, I say fill equals fill color. So in other words, it's not hard-coded to that dark green. It's now going to use whatever the value of fill color is. And I do the same thing on line 369, which will determine the background color of my gender labels. Okay, so I'm going to run my function now, and let me create a single gender plot for women. There we go. Looks pretty good. Now, to show you how I would put this all together, I'm going to again create a women plot for Benton women. Then I'm going to create a men plot, and then I'm going to use patchwork like I did in the last video and blog post to put everything together. Looks good. Now at this point, if I wanted to make a population pyramid for another county, say Multnomah, I could just switch Multnomah, run this, and I get a population pyramid for Multnomah. And that's pretty good. But I can even go another step by combining everything into a single population pyramid function. So down here, what I've done is I've created a function called population pyramid combined plot, which is a function that just takes one argument, county to filter. And what happens when you run this argument is that it's automatically going to create a women plot for whichever county you choose. And to create that women plot, it's going to use that other function, population pyramid single gender plot, in order to generate women plot. It'll do the same thing for men, and then it will stitch those together with our age labels plot in order to create a population pyramid. So now I can create a population pyramid combined plot for a county you haven't even seen yet. Gilliam County. Looks good. Wallowa County. Looks good as well. At this point, our function can create a population pyramid for any county in Oregon with just one line. So I hope this process of turning code to make a single population pyramid into a function has been useful. If you have any questions, put them in the comments below, and I'll look forward to hearing from you.